Hello everyone, and welcome to today's webinar, Introduction to Kubernetes Network Policy with Use Cases. Glad you could make it. So I am pleased today to announce our speaker, who is Cody McCain. Cody McCain is a Senior Solutions Architect with over 3 years of experience building and securing apps in Kubernetes, which I think is exactly as old as Kubernetes is, so he's been there since the beginning. He's a security advocate, regularly leading meetups and workshops on networking and network security, especially around Kubernetes. And he's also been implementing Kubernetes network security solutions at top financial firms and services companies, manufacturing enterprises, and customers of Tigera. So he is definitely qualified to speak on this topic. But before I hand the webinar over to Cody, I have a few housekeeping items I'd like to cover on this presentation and the BrightTalk webinar platform. First off, today's webinar will be available on demand almost immediately after the live session, and it will be accessible through the same link and on our BrightTalk channel. We've also added some attachments and links which are available through the Attachments tab in your interface. You can find some content there, including a link to our guide to implementing Kubernetes network security and some other links. And if you want a copy of today's slides, we can send those to you after the session. And next, we'd love to hear from you. So if you have questions during today's presentation, please feel free to ask them. Ask them as real time as you want to, and we will try to get to the questions as they come, because today's presentation is a very technical one, and we'd like to take the questions when they happen. But we also have reserved some time at the end of the presentation for a full Q&A where we will be able to get to all the questions you guys have. If we can't get to any of the questions, we will do our best to answer them afterwards by email. So now, without further ado, I hand it over to Cody. Cody?
Thanks. I appreciate it. And it looks like we've got a good number of attendees today, and excited to start sharing with you what I've learned in the trenches in dealing with the new paradigm of workload orchestration and how do we secure that, especially from the network side. So let's go ahead and dive in. So we're moving to microservices, right? We're taking our monoliths and we're decomposing our monoliths into smaller services. And if you think about a monolith used to communicate between all the components all in process, right? I'd have a bunch of libraries that I would compile together to build my application, and the different responsibilities and the concerns of the application were represented and decomposed into libraries that we compiled into one executable. And so when I needed to communicate between those, all those are various, basically library calls that we would make. And as now we've gone and started to decompose these monoliths into microservices, we've replaced the intercomponent communication now with network communication, right? So we've now made each one of these components first-class citizens on the network. That opens us up to quite a bit of things that we now need to be concerned about. No longer am I protected within my process space. I'm now actually potentially sharing data and other bits of information that my components need to communicate with each other over an open network. So in the past, the way that we've approached this problem is that we've said, okay, what we will do is we'll put a perimeter up around our data center. And we will make sure to keep all the bad guys out of the data center. And within the data center, I can decompose my monolithic application into all these parts, but it'll be safe because I'm within the boundaries of this protective barrier. The unfortunate thing is there's really only two types of organizations in the world right now. Those that know they have an advanced persistent threat and those that don't. So what does that mean for you as as a organization? We always have to assume that our network has already been penetrated by some type of a threat. These threats come in a multitude of ways. Again, they could be a zero-day attack or other type of APT. They could have come in via a rogue image that you deployed if you're using Kubernetes and have moved into containers. Maybe a container got through that didn't get scanned appropriately, and there was a threat embedded within it. No matter how the threat arrived at the network, now we're inside of that barrier, and we're no longer able to protect our other components, and now we have east-west spread capability for that threat. What we want to do is we want to prevent that from happening. And the easiest way that we can do that is erect barriers around every workload that we have running. So basically every microservice or component or virtualized workload of our application, we're going to erect a barrier around it and be very explicit and state the intent on what traffic we want to allow into that component and what traffic we want to allow out of that component. And by doing this, even though a component gets attacked, which it will, we've now reduced the blast radius of the impact of that attack. The other question that we have to ask ourselves is, okay, a lot of times when we think about firewalls and erecting firewalls, we talk a lot about how do we prevent various types of ingress traffic into the workload or the thing that we're protecting. And while we still need to keep that in mind, it's extremely important to ward off attacks that are happening externally. It's equally important to prevent any type of egress action. The problem is that once a workload has been attacked, if we only have ingress rules in place and are only concerned about traffic that is inbound into the workload, and haven't thought about putting policies in place that prevent outbound communications or egress traffic out of that workload, it makes it very easy for a threat to spread on the network in an east-west direction. So let's imagine that we have, what does this look like in the real world? Let's get pragmatic about this now. Let's imagine that we have an application, we're a retail shop and we sell widgets on the internet. And so we have a front end of our application that's called the product page. And behind the scenes, we've decomposed this monolithic application so that the details for product page, if I want to find the product details or pull in the reviews that have been done about my product or look at the ratings about my product, all of that information is being served up by different microservices that have, a singular concern that they will provide information for. And so the service graph may look something like this. I have a product page, and it's going to have a dependency on another microservice called details. It may also depend on a reviews microservice, and in turn, the reviews microservice may need to pull in additional ratings information from another microservice. What we want to do is we want to create network policies that protect each one of these individual components. Now let's also imagine that we are an international company, and we have sharded our data so that we keep it local to the consumer. So we've got a couple of US data centers, and we may have a couple of European data centers as an example. I still have the same logical flow, but now I'm going to be hosting duplicates or replicas of services in both geographical locations. So the first thing that I might want to do, if I was thinking of this as a developer, is I think about the service graph as a logical concern, right? I need to make sure that my application functions. I really don't care whether it's in Europe or the US. I just know that my product page needs to be able to make an API call to my reviews page, and my reviews page needs to make an API call to the ratings page. And as long as I can do that, I know my application is going to function. However, there's another role within my organization in compliance that says, that's great, but we need to make sure that from a data sovereignty perspective, that US data stays in the US and the EU data stays in the EU. And to do that, we want to make sure that the microservices of the application that are in the EU can only talk to microservices in the EU and vice versa for the US. So, taking that into account, we have different concerns that we need to meet now from a network security policy perspective. So the first concern was the developer. He wanted to make sure that he could have a very explicit way to describe what was allowed in his service graph. And so I've represented that here. We have different roles And we need to write policies that map to these roles that say things such as a product page role can talk to a review role can talk to a ratings role. At the same time, we also want to have policies in place that say anything that is tagged as belonging to the U.S. can only talk to other components within the U.S., and the same thing for Europe. Now, one subtle thing that I've introduced into this picture that I didn't talk about yet is the concept of metadata that describes my workloads. The great thing about using orchestrators such as Kubernetes is that as I spin up workloads, I'm able to describe those workloads with a lot of different properties called metadata, and in the case of Kubernetes, they're actually labels. And the great thing about labels is they're multidimensional. So in this case, I've used two different types of labels. I've got a role label that describes the logical service graph, and I've got a geographical label that is going to help me make decisions regarding data sovereignty and what components can talk to one another. So let's talk about what Kubernetes network or how Kubernetes network policy is going to solve this problem. Number one, we've already talked about labels. We know that Kubernetes network policies are going to have some way to know which workloads to enforce their policies against. It's similar to a traditional firewall. I could write a firewall rule, but I have to provide an IP address in the case of a traditional firewall to say, I'm only going to allow this traffic to and from this particular IP address. Now, the challenge within Kubernetes is that the workloads are dynamic and they're constantly changing. Things like IP addresses are actually ephemeral. So I need another mechanism by which to apply the rules that I'm going to create or the composition of those rules in a policy. I need a way to say these rules apply to this workload. And so what we're going to do is loosely couple those rules to a workload using the metadata of that workload or the labels. Additionally, I want to make sure that I can describe these rules so that they can be repeated in automation. I want to be able to use them in automation and be able to create a declarative infrastructure. And so by using Kubernetes network policy, the entire Kubernetes configuration API is built on a declarative nature. So I will describe using a YAML configuration what policies I want, and as soon as I apply them, Kubernetes and the underlying network plugin, which in this case will be Calico, take the steps to enforce that declared configuration. So what would we use this for? We've already described two use cases, but it could also be used for multi-tenancy, additional data classification if I had different levels like top secret versus confidential versus public. It can be used for other types of compliance enforcement. So if I was doing payment handling and dealing with payment cards, I could have policies that would say something to the effect of PCI workloads can only talk to other PCI enabled workloads. And then finally, I can do security enforcement. And so this allows me to write policies such as being able to embargo any inbound or outbound traffic to a block of IP addresses, or to disable SSH globally within an application cluster, or to restrict which DNS server I can reach. Those are all great examples for using network policy. So now let's dive another layer deep and actually see how did we implement a particular part of that logical service graph. So what I have here on the left side is the YAML representation of a Kubernetes network policy. Here at the very top, we see that the first thing we have to do is describe to Kubernetes what type of configuration that we're sending it. Kubernetes is driven by versioning various APIs. So the first thing we have to do is tell it what version of the networking API we're sending configuration in for and what specific type of configuration this is. And so in this case, it's a network policy. The next thing that we need to describe is how do we identify this policy? And this information is used along with additional metadata to restrict who can update this policy and make changes to the configuration. This is where we actually, in the pod selector, do the binding of the policy to a workload. So remember we talked about using loose coupling to bind policies. Loose coupling is a great mechanism for an orchestration platform such as Kubernetes, because at any given point in time, we could need to scale up the number of workloads for a particular service, maybe scale down, maybe add additional services that provide a similar behavior. By using loose coupling of a policy, I don't have to recreate or edit my policy every time I make a change to the workload topology. Rather, I am able to ensure that any workload that I'm starting up has the appropriate metadata, and the underlying network plugin, again Calico, takes care of dynamically applying and enforcing the policy as it matches the workload's metadata with the network policy metadata. So I got a question that just came in. It says, this looks like a CRD. This is very similar to a CRD, except that it's actually a native Kubernetes configuration resource. For those that don't know, a CRD is a custom resource definition, and that's a mechanism that we can use to extend the functionality of Kubernetes. One other clarification I would like to make at this point, and I'm not diving into a lot of details here on this, but I will have a slide on it here momentarily, is that there is a difference between what I would consider a bog standard Kubernetes network policy and a native Calico network policy. If you want to compare the two, think of the native Calico policies, which is implemented as a CRD, as a superset of functionality over just the bog standard network policy. You can use the two interchangeably. They will work with each other, but if you want additional functionality and you're using Calico as your underlying network plugin for enforcing network policy, then you can use a Calico network policy which gives you extended functionality. Finally, we have to actually describe the rule for the policy, and that's what this section does here. In this section, we're saying that we want to accept any inbound traffic on port 6379 or any TCP inbound traffic on port 6379 from any source that has the metadata role is ratings. Notice that I didn't say use any IP addresses here. I didn't say I only want to accept traffic from this IP address or this specific workload. This policy could accept traffic from only one rating service or multiple rating services. As long as it has the right metadata that matches the rule, we're going to allow inbound traffic and inbound requests from that source. Now, I mentioned just a while ago that the Calico policies are a superset of a standard Kubernetes network policy. And I've just put them side by side to show you that there is some slight differences in the way that you specify the policy. But the key differences that you'll really want to note here are the additional features that are added by Calico and also our commercial policies. Things such as being able to order policies. Ordering is not supported in the standard Kubernetes network policy. There's no such thing as a deny. You only have allows in the standard Kubernetes network policy. Additionally, in Kubernetes clusters, there's a concept of namespace. And namespace is many times used to separate tenants. When you're writing policies as a platform administrator, many times you might want to write a policy that applies to all the namespaces. Using a standard Kubernetes network policy, you only get policies per namespace. Additionally, standard Kubernetes network policies only support TCP and UDP. With a Calico network policy, we're able to support any IP protocol. We can also select not only on the metadata for a workload, But in the global policies, for example, we can select on namespace metadata. Every resource, every configuration resource within Kubernetes can be labeled. And so we use that fact to be able to have a selector that says if inbound requests are coming from a namespace with a certain set of labels, we can also match on those labels just like we would match on a standard pod or the workload layer. Finally, one of the key things that we provide with Calico policies is the capability to include other workloads in our policy domain, but that may not be part of the actual orchestrator or not part of the Kubernetes cluster. You know, I'm sure that all of you are developing greenfield applications and you have no existing legacy databases or other services that you need to connect to. But for those of us that do, this is a great way to include those legacy services in the same policy domain. So all we require is being able to run our Calico or Tigera agent on those external VMs or bare metal machines, and we can enforce the same types of policies that we do internally within a Kubernetes cluster. For example, we can have pod-to-pod communication or pod to VM or pod to external bare metal machine, and all of the same semantics would apply. Finally, our commercial version offers tiering, which then allows you to separate the concerns of who is authorized to change which policies and to be able to set precedents on which policies supersede other policies. And this is great for global compliance or global security functions that want to be able to write policies that can't be overridden by a developer or other line of business or application group. So another thing to consider when you're writing policies, and this is actually one of the key differences that sets apart and I think makes your policy landscape simpler than it is in a traditional firewall appliance paradigm. When you're talking about writing traditional firewall policies, you're typically talking about writing a set of rules for a particular application or a particular endpoint. However, with metadata now attached and available on our workloads that we're protecting and being able to write policy that targets the metadata rather than the concrete workloads themselves, this allows us now to separate our policies in the same way that we separated our monoliths, right? We decomposed our monoliths into microservices. We should also be able to decompose our application firewall rules or policies into micro-policies. That is, each micro-policy is only dealing with a very specific concern or behavior that it wants to protect against. Let's imagine that we have some foo service out there, and we want some foo client to be able to consume that foo service. In this case, we write two policies. Matter of fact, most micro policies come in pairs. You have a producer policy and a consumer policy. But the great thing about micro policies is they can be composed. So for example, I could introduce another client that not only needs to consume from foo as a client, but it also needs to consume from bar. Now, since I have decomposed the policies into separate policies, all I have to do is ensure that the workload has the right labels and the right micro policies then will bind and enable the behavior that I intended. So that brings me to the end of the technical discussions, and I want to open up the floor now for any questions that you may have about network policies.
Hey, Cody there. It's Michael. We have a question here that says, can you talk more about approaches for balancing security when utilizing non-production environments?
Approach for balancing security when using non-production environments. That's a great question. So one of the things that, Kubernetes, one of the reasons we go to Kubernetes is we want to move agilely. We want to iterate often, deploy often, be able to evolve different components of our application at different rates. And if we drive all of the policy creation, because we want to do this in a safe way, So if we drive all that policy creation through a central authority, say a central firewall or network team, all of the agility gained in the actual development of the application and its execution in terms of deployment comes to a halt when it hits the centralized policy enforcement, because now I have to wait on one single team to make sure that all of the firewall rules get created appropriately. Also, it makes it difficult to be agile, because in a general compute environment where I'm orchestrating all my workloads, there is no guarantee that my workload is going to run on any particular node. And so that workload may be scaling and moving around. And so I want to give the developers a little more capability to not only develop their network policies, but to be able to test them in testing, and then be able to roll them out in a controlled way. So let me talk about those two approaches. Number one, the people that understand the service graphs best are going to be the developers. They know exactly what data needs to be grabbed from each part of the application, and they also know what ports and protocols they're going to use to do that. So typically we should leverage the developer's knowledge in writing network policies that address the logical interconnections of the application, or the logical service graph. We also want to make sure that the developer has the means necessary to deploy those policies and to test them before we get ready for production. And since a network policy is just another Kubernetes resource and it works on labels, we can follow the same patterns that we would in rolling out any other Kubernetes application and do things like canary deployments and blue-green deployments and have our policies participate in those tests. Finally, by separating the concerns and having the developers focus on the technical aspects of the policy, that we can then delegate in the commercial product. If you use tiering, for example, we can delegate more of the relational aspects of the policy, things such as the PCI workloads can only talk to the other PCI workloads, which has nothing to do with ports and protocols, by the way, to a compliance team or compliance tier. And having those types of separation of duty, the capability to agilely deploy changes, and also to be able to test those changes without fear of bringing down an entire application, is all what make network policies very attractive to an agile software development lifecycle.
Okay.
All right. Another question here. If we have a set of micro policies, is there a way to visualize or test the aggregated effect of the policies? So currently we have a way to visualize the flows that are active within a policy. There are some roadmap discussions that you can have with us after the fact, where we are talking about the best ways to be able to have kind of a what-if scenario visualization. And so these are things that we're certainly working on. One of the things that I would encourage you is if you're unsure of what the effects of policy may have, we also have a way to put the configuration in a profiling mode. And so in effect, you write policies that deny things, but while you're in the test cluster or staging cluster, you can put it in a profiling mode that says, I'm going to go ahead and allow the traffic, but we're going to log everything, all the flows that occur. So then I can go back and adjust and clean up any of the policies that I've already written that got violated during that profiling session. I got another question here that said, what monitoring and auditing tools do you recommend? We come out of the box in the commercial version with Prometheus-enabled control plane that gives you a ton of metrics about the flows that are occurring, the policies that are being acted on, how traffic is being impacted, etc. We are really agnostic to the underlying mechanism you want to use to collect that data and aggregate it into a time series database or other visualization. We do have some examples that we can demonstrate that bring that information into, say, for example, an ELK stack or an EFK stack and visualize that in Kibana. In terms of logs, we also are agnostic there as well. We just, produce standard logs. Those can be accessed either off the disk or journal control, and you can collect them however you wish and ship them however you wish. We typically, in our demos, use something like either the ELK stack or the EFK stack to ship those logs into something like Elasticsearch for indexing. Any other questions?
Okay. Well, hey, Cody, thanks a lot for presenting, and thank you, everyone, for attending today's webinar. As we mentioned, as you can see on the current slide, we have a guide for setting up security, implementing security with Kubernetes that is available for download. And also, we'd love it if you join us for our next webcast, which is coming up Tuesday, October 23rd, in essentially 2 weeks. And this will be on compliance in dynamic Kubernetes environments. So we hope you join us for that. It's really easy to join because you have already signed up for Bright Talk. All you need to do is go to our channel and click on that webcast, and you are automatically signed up. No forms to fill out. It's awesome. And we've already gotten to the Q&A. If you want to schedule a demo, you can go to tigera.io/demo and schedule a demo of our software. And with that, that brings us to the end of our webinar. We'd like to thank you guys all for attending. Cody, thank you for a great presentation. And everybody have a great day.
Thank you.